Logging into the multi-tech conduit web GUI. And here we can see that the conduit is connected to the home router so that it has internet access as well. Now let's go ahead and configure the LoRa WAN network settings. And in the network settings, let's make sure that the channel plan is set to US 915 and the frequency subband is selected as 7. Let's also make sure that the network mode is set to public LoRa WAN and the join delay is 5 seconds. Now under key management, let's make sure we have the local network settings enabled and we have a network ID and passphrase of choice selected set. And now if we go back to the LoRa WAN dashboard, we should see the network status being shown as running. Let's go ahead and launch a Node-RED instance on the conduit. So let's go ahead and launch the instance, and as we can see we have an instance running on the multi-tech conduit here, and we have a flow defined with a LoRa node in place and an output message payload. And we have deployed this particular flow at the moment. Let's go ahead and load the required firmware on the xDot module. For this particular case, we'll be loading the .AT firmware, and we can also load the corresponding LoRa stack libxDot library that is required in this case here. And let's go ahead and import that into a compiler, embed compiler as well. And as we can see here in our compiler instance that is open here, we have the .AT firmware loaded up, and we have the libx.embed 5 library included alongside it as well. Now let's go ahead and compile this. So we have downloaded the firmware. Let's go ahead and load this onto the xDot module. And once this has been copied over to the xDot module, let's go ahead and open up a serial port, serial connection to the USB UART port, which is what we're doing here. And once we have done that, let us go ahead and press the reset button on the xDot module. And once we have done that, type in the AT command, and in this case it should return an OK output status, which signifies that we have loaded the correct firmware that is to be used here. So next, let us go ahead and configure the xDot module so that it can communicate with the multi-tech conduit. Let's go ahead and set commands and then join to the network. And let's confirm that I successfully joined by sending out the following command and verifying that it actually shows up here. So over here we can see that the message actually shows up. Let's just clear the window once again, and if we send another command, we can see that the message actually shows up here, which in turn confirms that the xDot module is in fact able to communicate with the multi-tech conduit. Uploading the sensor data from the xDot module over to the multi-tech conduit, and for this we would first load an example programs, which would be the .examples package, and along with it let's also go ahead and load the necessary library, specifically the libx.embed 5 library. And in the embed compiler instance open here, we can see that we have the .examples package loaded, and if we go into the example underscore config.h file, let's make sure that the active example indeed is OTA example, and the channel blind defined is indeed ES915 as was configured in the original conduit configuration. Now if we go into OTA underscore example dot cpp, we need to make sure that the network configuration settings are configured as was done with the conduit initially. So we have the network name, the network passphrase, the frequency subband, and the join delay configured accordingly. At the same time, we also need to have the necessary handler in place to make sure that we are able to read the sensor data and parse it accordingly over to the conduit. So for that purpose, uh, we actually read the sensor data, and we push the data out. So and this is the thermistor function, which basically reads the temperature and converts it into Celsius, and returns the same to the calling to the call. And this data is pushed out by the xDot module over to the multi-thread conduit. Now let us go ahead and compile this code. The program has compiled. Let us go ahead and download the binary and load this onto the xDot. And once it has been loaded onto the xDot, we should see the sensor data that is being picked up by the xDot being sent over to the conduit, in which case we should see the output show up on the Node-RED instance that is running on the multi-thread conduit that we have here. So in this case, we can see that the temperature values that is being recorded by thermistor is being sent over by the xDot module to the multi-tech conduit. Is later pushing the data from the multi-tech conduit over to the AWS IoT dashboard, where we can visualize the data. For this, first we need to make sure that the private keys and certificates are loaded onto the conduit. For this, let us first log into the conduit via SSH. Enter the password that was used to log into the web GUI initially. And once we are in, since we've already copied over the certificates to the conduit via SCP, we should find the certificates residing in this folder here. So this is necessary as we define the HTTP request module. We need to define or enable the SSL or TLS connection, and in which case you'll have to point to the certificate, the private key, and the CA certificate. And these files, as we can see, are present on the machine or on the conduit at this particular location. So that has been configured against the HTTP request node in the post mode and post method. Another topic of concern here is the label or the dashboard topic that is being provided. We need to make sure that we set up or we subscribe to the same topic with the same name on the MQTT client dashboard in AWS IoT. So that is another thing that we would have to look out for here. And this is basically our custom endpoint of our AWS IoT dashboard, which has been mentioned here. And this is basically our HTTP request, and prior to that we convert into JSON. And if we were to deploy this topic with the QoS set to 1 and subscribe to the topic, and subsequently clear the debug messages, we should actually see that as the values get populated on the debug console here in the Node-RED instance that is running on the multi-tech conduit, we should see the same set of values getting populated at the IoT dashboard as well. So as we can see here, this is the latest value that has been pushed. It is at 25 degrees Celsius, and going back to the debug console, we can confirm that the latest value was indeed 25, and the value after that was pushed was also 25 degrees Celsius. So as we can see here, the data that is being collected by the xDot module is being sent over to the conduit, which in turn pushes the data out onto the internet and subsequently onto the AWS IoT dashboard that has been set up here. In a similar fashion, we should also be able to push data onto, say, a things for instance, and in turn visualize the data in a graphical manner. Thank you.